Hey, I hope you liked my joke. I wanted to make sure that you guys had some funny ones. So today we're going to talk about solubility curves, which is just really a graph of solubilities. It's a pretty easy lesson, so let's go ahead and get started. As we talked about this yesterday, as temperature increases, you can dissolve more and more of a solute if it's a solid. Now, if it's a gas, you can dissolve less at a higher temperature. Some important vocabulary terms that we talked about yesterday: saturated, unsaturated, and supersaturated. A saturated solution contains the absolute most solute that can be dissolved in the solvent at that temperature. An unsaturated solution means that if I can dissolve a cup of sugar in my Kool-Aid and I only put a half a cup of sugar in my Kool-Aid, it's an unsaturated solution. I could add more to get to that saturation point. A supersaturated solution is one that has to be made. You'd increase the temperature of the solvent and dissolve more than you could normally. Maybe I want to dissolve 2 cups of sugar in my Kool-Aid. So I heat it up, I dissolve my 2 cups in there, and then I cool it back down to room temperature, because normally I could only dissolve a cup, but by heating it up and then dissolving and cooling back down, I now have a supersaturated solution. So those are those 3 vocabulary terms. All right, so this is one type of solubility but solubility chart that you'll see. I hope you can see all of these. I'm going to try my best to work through this for you with my mouse. So number 1, do the last 3 substances in table 18.1 increase or decrease their solubility in water temperature, or in water as the temperature increases? Well, look at these last 3. There's hydrogen, oxygen, and carbon dioxide. Let's see, first one, hydrogen goes from this at 0 degrees C. It looks like the solubility decreases for hydrogen. For oxygen, same thing. Solubility is going to decrease as the temperature increases. Carbon dioxide does the same thing. Now, why is that? Well, it's because they're gases. Gases decrease in solubility as water temperature increases, which is the reason that in the summertime, when a lake gets really warm, because the temperature outside is so hot, the water temperature rises in that lake and it loses the dissolved oxygen, which can cause fish to die because the fish need the oxygen to live. So in the summertime, fish kills can occur because of the depletion of oxygen in that water body. Number 2, is a solution of 45 grams of potassium chloride dissolved in 100 grams of water at 50 degrees C, unsaturated, saturated, or supersaturated. So what we do is we have to find, here, I'm going to try one of these things. Let's see, this is a highlighter that's been, let's try highlighter, and we're going to try, yeah, okay, we'll do yellow. 45 grams of potassium chloride at 50 degrees. So find potassium chloride. Potassium chloride's right there, potassium chloride. Right there, and we're talking about at 50 degrees, so follow that table over. Boy, I wish I could draw a straight line, but it's not any different than in the classroom. Right to there. Okay, so right there is the solubility of potassium chloride at 50 degrees. Is that thing saturated, supersaturated, or unsaturated? Well, I've dissolved 45 grams, and look how much can dissolve at 50 degrees. 42.6 can dissolve. So what that means is that it's unsaturated, or I'm sorry, it's supersaturated. That means that I've dissolved more at that particular temperature at 50 degrees than I normally could. I've dissolved 45 grams, but only 42.6 grams normally would dissolve. So it's a supersaturated solution. Is a solution of 222 grams of silver nitrate dissolved in 100 grams of water at 20 degrees C, unsaturated, saturated, or supersaturated? Well, let's find this one. I'll do highlighter again, but not going to do same color. 222 grams of silver nitrate at 20 degrees. So let's find silver nitrate. There's silver nitrate. Follow it over. That's 0 degrees, 20 degrees. Okay, at 20 degrees, I can dissolve 222 grams. Well, it says that the solution already has 222 grams. So what is it? Saturated, unsaturated, or supersaturated? Yep, saturated. Is a solution of 3.5 grams of potassium chlorate dissolved in 100 grams of water at 0 degrees, unsaturated, saturated, or supersaturated? Well, let's find another color. Let's see. Potassium chlorate is up here. There's potassium chlorate, and it's at 0 degrees. So let's see, at 0 degrees, what's going on with potassium? Look at that straight line. There's potassium chlorate at 0 degrees. So we have 3.5 grams dissolved. Well, at 0 degrees, I could dissolve 4 grams. So that means it would be what? Yep, it would be unsaturated because I could dissolve a little bit more. I could dissolve another ½ gram. Which solute has the highest solubility at 20 degrees? Well, let's see. Here's 20 degrees right there. Which one of these has the highest solubility? Yeah, it looks like right there. So what is that? Sugar. Sugar has the highest solubility at 20 degrees. Which has the highest solubility at 50? Well, here's 50. And then we go down and we go down and we go down. Wow, see, you would think it would be sugar, but not everything has the same solubility has a linear increase. This one clearly doesn't. So look here, silver nitrate, it looks like, has the highest solubility at 50 degrees. All right, this is how you'll usually see the solubility graphs. Let's see, but normally we put more things on them, so be prepared to look at a little bit of a messier graph, but let's see what we can do with this one. This is a pretty simple one. How many grams of sodium nitrate are dissolved at 60 degrees? So you follow that up, let's see, grab a color, 60 degrees, you follow it up, there we go, to the line. And then you follow the line all the way over. Oh, wow, your teacher could only draw a straight line. So it looks like somewhere in between 120 and 140, we're going to pretend I drew a straight line, and we're going to say 130. How many grams of sodium nitrate could be dissolved in 300 grams of water at 60 degrees? Okay, well, this is kind of a trick question because these solubility graphs are in 100 grams of water. Okay, this is asking you about 300 grams of water. So what do? Well, you find the solubility on this graph in 100 grams of water and you multiply it by 3. It's really easy. So sodium nitrate, 60 degrees, how much could dissolve? Well, we said it was 130, so 130 times 3, seriously, I got to do that math in my head, 390 grams. All right, how many grams of sodium nitrate could be dissolved in 110? Well, here's 110-ish. Again, if I can draw a straight line. Okay, so, whoa, that's the straight line. There we go. So what you have to do is you have to pretend like the graph keeps going. It looks like it's going in about the same direction, so you just kind of follow it and go, okay, well, what would it be? It would probably be somewhere along there. So at 110, it looks like probably about 200 grams would be dissolving at 110. You just have to draw the graph out and kind of make your best guess. Okay, graph B. What solute dissolves best when the water is 60 degrees C? Okay, so this is a busier graph. This is more like what you're going to see. What solute dissolves best when the water is 60? So you find 60. I don't know that I want that color. Let's go with that color. 60 degrees is right here. So you follow that 60-degree line up to whichever of the solutes has the highest solubility at that particular temperature. Sorry, right there. So it looks like sodium nitrate, that's the sodium nitrate line. So sodium nitrate dissolves best at 60 degrees. Which solute has the lowest solubility at 60 degrees? Well, you do the same thing, but you find the line that intersects with that temperature line right there. So at 60 degrees, which one dissolves the least? Which one's got the lowest solubility? Well, it's that ytterbium sulfate. How much ammonium chloride dissolves in 100 milliliters of water at 65 degrees? So here's ammonium chloride right here. Okay, it's going to be that line. 65 degrees. So follow this up to right there. Okay, we're going to pretend it's right there, a little bit higher. There we go. At 65 degrees, it looks like it may be a little bit less than 60, 58, 59. That would be my guess. Okay, so next graph. Pick a different color. Pick blue. How much potassium bromide will dissolve in 500 milliliters of water at 45 degrees C? Okay, look, see, you got 100 grams of water, which is 100 milliliters of water, but now we're asking about how much will dissolve in 500 milliliters of water at 45 degrees. So we find our potassium bromide right there. There's my line for potassium bromide, and there is about 45 degrees. Okay, at 45 degrees, somewhere in the neighborhood of probably 79 to 80 grams is dissolved. So if it's in 500 milliliters of water, we're going to go with 80 so that it's a round number to multiply pretty easily. 80 grams in 100 milliliters of water would translate into 80 times 5. So that would be like 4,400 grams, 400. Yeah, I'm pretty sure. Your teacher doesn't really need a calculator to do that, but remember, I've been off as many days as you have. So 80 grams in times 5. Yes, 400. It's exactly what I thought. Kinda. All right, number 8. If you stir 150 grams of potassium nitrate in 100 milliliters of water at 70 degrees C, will it all dissolve? Okay, so where's potassium nitrate? Potassium nitrate's up here, so it's this line right there. We're talking about 150 grams at 70 degrees. Well, here's 70 degrees, so we follow it up and see what's going on at 70 degrees for potassium nitrate. Let me get all the way up there. There we go. So at the 70 degree mark, it looks like somewhere around 120 grams is dissolved. So let's see, 120. Look at that, 120 grams. Well, I've stirred in 150 grams. So will it all dissolve? Nope, it will not all dissolve. About 30 grams won't dissolve. If you stir 200 grams of sodium nitrate in 100 milliliters of water, that's 45 degrees C, how many grams won't dissolve? So we already know that some of it's not going to dissolve. So we have to look and see how much is going to dissolve. Well, sodium nitrate right there. So it's this line right here. So that's sodium nitrate. Yeah, sodium nitrate. Let's see. 45 degrees puts me about, and keep going with this line and hit sodium nitrate. Okay, there we go. Right there. Okay, at 45 degrees, it looks like probably, again, if your teacher could draw a straight line, it would look probably about 100 grams. So if I put 200 grams in there, how much won't dissolve? 100 grams won't dissolve. 100 grams will dissolve, but I tried to put 200 in there. All I'm going to get that dissolves is 100. Alrighty. How many grams of sodium chloride dissolve in 200 milliliters of water that's 50 degrees C? Well, there's 200 milliliters. All right, remember, this is 100. It says 100 grams, but water has is 1 gram per milliliter, so 100 grams is 100 milliliters. 200 grams of water, sodium chloride, 50 degrees. Well, here's my sodium chloride right there. Okay, 50 degrees, follow it up. And it looks like the solubility of sodium chloride doesn't change much over temperature with increasing temperature. Looks like somewhere under 40 grams. So let's just say 39, just for sake of argument. 39 grams will dissolve in 100 milliliters of water. So in 200 milliliters of water, that would be 78 grams, I believe. So yeah, 78 grams will dissolve. Number 11, if you have 100 grams of potassium nitrate in 100 milliliters of water at 100 degrees C, is this going to be unsaturated, saturated, or supersaturated solution? So potassium nitrate, way up there, that's this line right here. Potassium nitrate, 100 grams and 100 milliliters of water at 100 degrees C. Well, what you need to notice is this graph doesn't go to 100 degrees. So again, you have to pretend like the curve is going to keep going in the direction, approximately the direction that it's going. So it would go off the page somewhere. If you have 100 grams dissolved, well, look, I mean, at 90 grams, or I'm sorry, 90 degrees, you're looking at maybe 160 grams. So if I have 100 grams in there, that thing's going to be unsaturated. I could dissolve like probably 80 grams more on top of that. If you only had 50 milliliters of water as a solvent, how many grams of sodium chloride could you dissolve in 100 degrees? Okay, here's sodium chloride. We're going to pretend like it keeps going, but it doesn't really change all that much. And we have to draw it off the graph, the solubility graph, because we're talking about 100 degrees C. And again, this graph only goes to 90. So we're going to keep going and pretend like it doesn't change a whole lot, because it doesn't. But look, you have 50 milliliters of water this time. So when you have more than 100, if you have 200 milliliters of water, you double it. So what do you think you do if you have half the amount of water? Right, you divide it by 2. So however much will dissolve at 100 degrees, take half of that, and that's how much would dissolve in 50 milliliters of water. So at 100 degrees, it's going to be about 40 grams. So in 50 milliliters of water, about 20 grams is going to dissolve. Alrighty, how many grams of sodium nitrate would be needed to saturate 100 milliliters of water at 65 degrees C? Okay, 100 milliliters of water, so yeah, sodium nitrate. So let's find sodium nitrate right there. So it's this line right here. 65 degrees C, follow that up. It looks like about right there. It looks better when I don't draw the line. So sodium nitrate at 65 degrees looks like somewhere around 120 grams would dissolve at, you would need 120 grams of sodium nitrate to saturate the solution at 65 degrees C. Test tube with 85 grams of sodium nitrate or potassium nitrate in 100 milliliters of water at, I think that's 40 degrees, but my head is in the way. Would look clear, which would mean it would be unsaturated. Would it be clear as a saturated solution, or would it be cloudy, similar to Kool-Aid? So 85 grams of here's my potassium nitrate up here. It's this line right here. 85 grams at, we're going to say that's 40 degrees. So we're going to follow it back down to where it hits 40 degrees. About right, somewhere about right there. It's going to hit 40 degrees. Oh, sorry, 40 grams. 40 degrees, so let's, I think I can erase it. Look at that. Technology's great. So 40 degrees, follow that up to potassium nitrate. There we go. That's 40 degrees. A test tube with 85 grams of it in 100 milliliters of water at 40 degrees. What would it look like? Well, at 40 degrees, it looks like I can only dissolve about 50 or 55 grams. So not all of it's going to dissolve, which means it's going to make a cloudy solution similar to Kool-Aid. Okay, it would be cloudy. It would definitely have particles floating in it because it wouldn't be clear. It wouldn't all dissolve. There'd be some particles left over. So that's it for today, I think. Nope, one more. Oh, this one's good. This one's about solubility of gases. So how does the solubility change for with temperature for gases? Well, look here. We have the temperature goes from 0 to 100. So as temperature increases, look what happens to the solubility of all these gases. They all decrease. As since solubility is decreasing as temperature is increasing, what type of relationship is that? Now remember that a direct relationship is one in which both variables increase. An inverse relationship is one in which the variables one will increase as the other decreases, which that's what this one is. Okay, so that's it. I hope you liked my joke, and I hope you liked this lesson on solubility graphs.